Hello and welcome to my channel. In this video we will solve problem 5 and 6 of chapter 14 linear programming in 12th class maths. Okay, so what we have to do in this fifth problem is maximize z, which is the objective function 3x plus 2y subject to x plus 2y less than or equal to 10, 3x plus y is less than or equal to 15 and xy greater than or equal to 0. Okay, so let us start solving the problem. We have already solved 4 problems of this exercise. Okay, so the same method we have to use it here. So solution, so let us write what is given to us. So given is maximum z equal to 3x plus 2y, okay, subject to x plus 2y less than or equal to 10, then 3x plus y less than or equal to 15 and xy greater than or equal to 0. Right, now what we have to do is we have to take the first inequality and we have to write the line corresponding to the first inequality. So that will be our line 1. So line 1 is nothing but x plus 2y equal to 10. Right, so now we have to make the table here for getting the line. So x and y will be equal to 10 minus x divided by 2. Right, so when x is 0, y will be 5. When x is 2, y will be 4. Right, when x is 4, y will be 3. So this is our table for the first line. Right, so now let us make the table for the second line. So line 2, so line 2 is nothing but 3x plus y equal to 15, 3x plus y equal to 15. So x is x and y is nothing but 15 minus 3x. Right, so when you have x equal to, suppose we take 5, okay, so we will get 0 here. Then when x is equal to if we take 4, right, so 15 minus 3 times 4, 15 minus 12, that is 3, and if x is equal to 3, we will get 15 minus 9, which is 6. So this is the table for the line 2. Right, now line 3, you know, line 3 is corresponding to the third inequality, which is nothing but x equal to 0, which is the y-axis, and line 4, which is y equal to 0, that is nothing but the x-axis. Okay, now let us draw the graph. So this is the y-axis, this is the x-axis. Right, x-axis, and this is the y-axis. So if we look at the table, we can know what scale we have to take. Right, so it is this 1, 2, 3, 4, 5, 6, right, and here 1, 2, 3, 4, 5, 6. Right, now let us draw the first line. So that is this table. 0, 5 is the first point of the first line, 0, 5. Then we have 2, 4. So 2, 4 here. Then we have 4, 3. That is this. If we join these 3 points, So we get this line, right? So let us name the line. It is x plus 2y equal to 10. Now let us draw the line 2, that is this 5 comma 0, that is here. Then we have 4 comma 3. 4 comma 3 is this point only here, right? Then 3 comma 6. So 3 comma 6 is here. Okay, so we join these 3 points like this, right? And let us name the line 3x plus y equal to 15. Three x plus y equal to 15, right? Now we will look at the solution regions of each inequality. So put 0 comma 0 in the first inequality, and by the way, line 3 and line 4, you know, line 3 is x equal to 0, that is the y-axis, and line y equal to 0 is the x-axis. Okay, now let us put 0 comma 0 in the first inequality, that is this x plus 2y less than or equal to 10. X plus 2y less than or equal to 10. So that is what we will get is 0 plus 2 times 0 less than or equal to 10, right? So that is 0 is less than or equal to 10, and this is true, right? So therefore the inequality is satisfied. So therefore the solution region is the half plane where point 0 comma 0 lies. Okay, if you look at this line x plus 2y equal to 10, the solution region is on the side where 0 comma 0, that is the origin, lies. So that means we will get this solution region here. Okay, here like this. Okay, now let us put 0 comma 0 in the second inequality. So put 0 comma 0 in the second inequality is 3x plus y less than or equal to 15. So that means that is 3 times 0 plus 0 is less than or equal to 15. So that is 0 is less than or equal to 15, that is true, right? So therefore the inequality is satisfied. Right, therefore the solution region lies, or solution region is the half plane where the point, that is the origin, 0 comma 0 lies. So if we look at the second line, this 3x plus y equal to 15, since the inequality is satisfied for the point 0 comma 0, right, the solution region will be on the side, or the solution region will be in the half plane where the point 0 comma 0 lies. So that means in this way, right? Okay, so this is the solution region. Now for line 3 is y axis, So that is this, and you know that if you have the inequality x greater than or equal to 0, that means the solution region is on the right hand side of the y axis. So like this here. Okay, and for inequality y greater than or equal to 0, that means the solution region for this line y, or the solution region for the inequality y greater than or equal to 0 is the region above the x axis. Okay, so that means this. Okay, so if you look at all the solution regions and take the intersection, then you will get this region here, right? This is the solution region. Let us name the corner point. So this is the origin. So we take the letter O, then this is A, right? This corner point is B, and this is C. Now if you look at the corner points, these corner points we know what it is, 5, 0, right? This also we know, the point B, why it is the same point. And if you look at the table, right, so this is the same point, that is the common point between the two lines, so no need to find it by simultaneous linear equation. Okay, so we have the point B, and C is 0, 5. Okay, so now let us find the values of objective function at the corner point. So at first of all origin we have to at the origin we have to find the value of z. So z is equal to 3x plus 2y, so we will get 3 times 0, right, plus 2 times 0, so that means 0. Now at a equal to 5, 0, right, 5, 0. So what we will get, z is equal to 3 times 5 plus 2 times 0, which is nothing but 10. Now at b equal to 4, 3, if we take, then z will be equal to 3 times 4 plus 2 times 3, that is nothing but 12 plus 6, which is nothing but 18, right. Then at c, which is 0, 5, z is equal to 3 times 0 plus 2 times 5. Okay, so that means 10. Oh, this is 15. 3 times 5 is 15. So that means if you look at the maximum you have to find, right, maximize. So maximum is at this point b4, 3, and the maximum value is 18. So that means the maximum of z is equal to 18 at the point B, which is 4, 3. Okay, so this is the solution of the problem. Now let us go to the next problem. So sixth one, minimize z equal to x plus 2y subject to 2x plus y greater than or equal to 3, x plus 2y greater than or equal to 6, xy greater than or equal to 0. So let us solve this solution. Let us write what is given. Given is minimize z equal to x plus 2y, right, subject to 2x plus y greater than or equal to 3. Then we have x plus 2y greater than or equal to 6 and xy greater than or equal to 0. Okay, so now let us we have these two inequalities, right? So corresponding lines we will write first. So line 1 will be corresponding to the first inequality, that is 2x plus y greater than or equal to 3. That means 2x plus y equal to 3, right? And x and y will be nothing but 3 minus 2x, right? So when x is 0, y is 3, and x is 1, y is 1, right? Then when x is 2, y is minus 1. This is the table for line 1. Right? Now line 2, let us take. So it is x plus 2y equal to 6. So that means x and y will be nothing but 6 minus x divided by 2, right? So when x is 0, y is 3. Okay, when x is 2, so you will get 6 minus 2 by 2, that is 4 by 2. So that means 2, right? And when x is 4, so 6 minus 4 by 2, that is 1. This is what you will get. Okay. This is the table for line 2. Okay, now line 3, line 4, line 3 is x equal to 0, which is nothing but the y axis, and line 4, which is nothing but y equal to 0, which is the x axis, right? So now let us plot the graph here. So if this is the y axis here and this is the x axis, okay, this is the origin, x axis here, y axis. Okay, and let us see what scale we have to take. So it is this 1, 2, 3, 4, right? Then here 1, 2, 3, 4. Then this is minus 1, minus 2, right? And then this is minus 1, minus 2. Okay, so first line we will plot. So first point of first line is 0, 3. Okay, so 0, 3 is here. Then we have 1, 1, right? 1, 1. Then okay, 1, 2, minus 1. So 2, minus 1, that is here, right? So let us join this. And let us name the line. The line is 2x plus y equal to 3. Now second line we will plot. So which is nothing but x plus 2y equal to 6. So again 0, 3 is the common point. Then 2, 2 is there here. 2, 2 and 4, 1. 4, 1 here, right? So if you join these 3 points, okay, yeah, if you join these if you join these 3 points, you will get this, that is x plus 2y equal to 6, right? Now let us find the solution region of the inequalities, and of course you know this, right? Y axis is x equal to 0, this y axis, and y equal to 0 is the x axis. Let us put 0 comma 0 in the first inequality, that is 2x plus y greater than or equal to 3. So that is 2 times 0 plus 0 is greater than or equal to 3, that is 0 greater than or equal to 3, which is false, right? 0 is not greater than or equal to 3, 0 is less than 3. So therefore the inequality is satisfied. Therefore the solution region is the half plane where 0 comma 0 does not lie. Okay, and if you look at the region where 0 comma 0 does not lie, so the solution region for this line we are finding, red line. So 0 comma 0 lies here, right? But the solution region is in the half plane where 0 comma 0 doesn't lie. That means in this region here. Okay, right, now let us put 0 comma 0 in the second inequality. Put 0 comma 0 in the second inequality, so which is x plus 2y greater than or equal to 6. So that is nothing but 0 plus 2 times 0 greater than or equal to 6, that is 0 is greater than or equal to 6 is false. So therefore the inequality is not satisfied. Here also I have written is satisfied, it is not correct, not satisfied. Okay, so the inequality is not satisfied, right? So therefore the solution region is the half plane where 0 comma 0 does not lie. Okay, so if you look at the second line, so 0 comma 0 is here. So for the second line also the solution region is in the half plane where the point 0 comma 0 does not lie. So that means here, right? So this is the solution region. For the second line. Now you know, for the inequality x greater than or equal to 0, the solution region is this. Okay, and for y greater than or equal to 0, the solution region is this, above the x axis. Right, so if you look at the intersection of all this region, we'll get this this region. Okay, and here in this way, so you are getting an unbounded feasible region here, right? So here the feasible region is unbounded, right? Unbounded. So what we have to do when the solution region is, or the feasible region is unbounded? First of all, you have to find the values of the objective function at the corner points. Okay, so let us name this corner point. So this is A, this is B, right? So only two corner points are there. So at A, which is what actually, yeah, we have to find that. So to find point A, so how to find point A? Now if you look at this line, green line here, so it intersects the x-axis, right, at point A. So to find point A, what we have to do is we have to take y equal to 0. To find point A, we have to take y equal to 0. So to find point A, put y equal to 0 in the green line, that means the second line, x plus 2y equal to 6, x plus 2y equal to 6. So x plus 2 times 0 equal to 6, so that is x is equal to 6 and y equal to 0 right here. So point A will be what? Point A nothing but 6 comma 0. Okay, so now let us find at 6 comma 0 the objective function will be what? So objective function is x plus 2y, so that means 6 plus 2 times 0, so that is 6, right? Now at the second corner point, and second corner point we have 0 comma 3, it is right here. So the point is common to both the lines, so it is 0 comma 3. So z is equal to 0 plus 2 times 3, okay, 6. So you see that the value of the objective function is same in both the cases. So what we have to do is consider this inequality. So you know how to find the how to write the inequality actually. So how it will be? So you have to take the right hand side of the objective function x plus 2y, and since we have to find the minimum, right, since you have to find the minimum, we have to take less than. If you had to find a maximum, we would have taken greater than. Now here you have to take the less than and then the minimum value of the objective function, but since both the values are same, so that means 6 is the minimum. Okay, now once you write the inequality, we have to write the table here, right? So x and then what will be y, 6 minus x by 2, y will be 6 minus x by 2. So when x is 0, y will be 3, when x is 2, y will be 2, when x is 4, y will be 1. Okay, so this is the table we get. Okay, and if we plot the line, what you will get? The line is what? The line is actually x plus 2y equal to 6, and if you observe carefully, this line which is there, it is same as the line which was in the second line of the problem, x plus 2y equal to 6. So that means the line that we have to plot is nothing but the green line only, right? This is the line that we have to plot. Okay, and now we have to find the solution region for the new inequality. So put 0 comma 0 in x plus 2y equal to x plus 2y less than 6. In this inequality we have to put, okay, Neve inequality. So what we will get, 0 plus 2 times 0 less than 6, so that is 0 less than 6, right? So this is true, so therefore the inequality is satisfied, right? The inequality is satisfied, therefore the solution region is the half plane where 0, 0 lies. So if we look at the solution region for the Neve inequality, it is this here, right, where 0, 0 lies. Now if you observe the feasible region, this is the feasible region, right, and this is the region of the Neve inequality, and you can observe that there is no common point between the two regions, right? There is no common point between the two regions, okay? The regions do not intersect, okay? So there is no common point between the two regions, and therefore the minimum value is nothing but the minimum value of the objective function, that is 6, okay? So since the feasible region and the solution region of this solution region of this inequality, x plus 2y less than 6 does not have common point, therefore so we conclude therefore minimum of z is equal to 6. Now the question is at which point you have the minimum, okay? If you look at this line, at both the corner points we have the same minimum value. So if at both the corner points you get same minimum or maximum value, then all the points on the line segment joining the 2 points will be the solution, okay? So so what we will get is at all the points of line segment joining uh, 6, 0 and 0, 3 joining points 6, 0 and 0, 3, okay? So I hope you have understood the solution of the problem. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.